So, in classification of systems, we come across linear and nonlinear systems. What is a linear system and what is a nonlinear system? Let's go through these first. Now, we can define a linear system to be if a system follows superposition, then superposition principle, then we can say that a system is a linear system. And what are the properties of superposition means? It has to follow basically two properties, additive and homogeneity. If it is homogeneity, it is the scaling property it has to follow. Whether it is sum of the response to the sum of the inputs or sum of the individual responses, it has to be equal. And additive property is also the same. Whether the response of individual sum of the responses of individual inputs has to be equal to the response of some of the inputs, then if both the equations are equal, then we can say that a system is a linear system. So clearly, if the response to the sum of the inputs is equal to the sum of the responses of the individual outputs as inputs, then we can say that it is a linear system. Now, there are some properties for this linear and non-linear systems also. And basically, design of linear systems is easier than the non-linear system. And the examples which we come across the linear systems are any filter can be a linear system. And the response of the linear system can be easily calculated using the convolution. And the analysis of the system can be easily done with discrete Fourier transform. And similarly, we have some properties for the non-linear systems also. Non-linear systems exhibit a complex behavior. They do not follow the superposition. They do not follow the homogeneity or additive properties. And for the applications where we construct a non-linear systems can be in audio processing, we can construct, or in image processing, or in a communication system where demodulation of certain signals, we can construct a non-linear system. For example, if you want to build a system which is voice generation, then the system which has to be built for voice generation is not a linear system, because there are different modulations we need in the sound. So that is possible only with the help of the non-linear systems only. And if you see the basic differences between linear and non-linear systems, these are the differences. The linear systems are predictable and analytically tractable. So they can be easily determined because they are guided by some specific procedure. So we can easily calculate the responses for linear systems. But if you want to construct a non-linear system, it is complex relative to the linear system and often more accurate for real world signals. They can be used for specialized techniques, required specialized analysis and design techniques in order to construct a nonlinear system. And if you want to verify whether a system is linear or nonlinear, here I have taken a small example where the response of the system y of n equal to x square of n. Now this means that if you give the input to the system as x of n, the output to that system is x square of n. That means the property or the transformation which is done in the system is squaring whatever input we give. So in order to test that, let us give two inputs, x1 of n and x2 of n. When we are given x1 of n, the response y1 of n equal to x1 square of n, because the system is squaring the input. The transformation of the system is squaring of the input. Even if we give x2 of n, it squares and gives the output. When we sum both the inputs before giving it to the system, when we sum the inputs first and then give it to the system will definitely square the inputs, but sum of the signals is square. And mathematically, if we check here, the response to some of the inputs is not equal to the response of individual inputs. So, as it doesn't follow the superposition principle, we say that the system is a non-linear system. Thank you.